Now let's start with an introduction to NFT development. In the last years, NFTs or non-fungible tokens have gained significant attention in the digital world as a unique way to represent digital ownership of assets. These are digital tokens that use blockchain technology to certify the uniqueness of digital assets, such as digital art, music, videos, and real-world assets, such as real estate. Here you can see some of the most popular NFT projects. NFTs are digital assets that are unique and cannot be replicated. This is one of the most fundamental elements of NFTs, and unlike other cryptocurrencies, NFTs cannot be exchanged one for the other because they are all unique. It's not like any other fungible asset. Another key aspect of NFTs is that they are stored on a blockchain, so it makes them immutable and traceable. It has all the benefits that blockchain technology provides. Then the value of NFTs comes from its uniqueness and its scarcity, so it makes them ideal for digital collectibles, tickets, art, and other stuff that are valuable because they are unique. Here are some of the technical requirements for NFT development. The first thing you need to learn is a programming language such as Solidity. Also, you will need to learn about some tools like Remix, Truffle, or Hardhat. Then you will need a cryptocurrency wallet such as MetaMask or Fluent to interact with the blockchain and pay for the gas fees. An NFT collection involves four main components. The first one is the digital art. This is the core of an NFT collection, which can be images, animations, videos, or whatever. Then we have technology such as IPFS, which provides decentralized file storage. This is normally used to store all the digital art of most NFT projects. It basically ensures the durability and availability by using peer-to-peer networks of nodes. Then we have the smart contract, which is the self-executing contract that defines the rules of the NFTs and its characteristics. For example, the total supply, the royalties, and the different functionalities to transfer or trade these NFTs. And finally, we have a front-end application. Most NFT projects have a user-friendly interface that allows users to connect their wallets and mint their NFTs, or select the digital art they want to sell, buy, interact, or just view them. This front-end application communicates with a smart contract and can trigger, for example, the minting transaction. Now let's talk about generative art. Most projects like CryptoPunks or Bored Ape Yacht Club are a huge amount of NFTs, let's say 10,000s of NFTs. And it's very difficult to create this art manually one by one. So normally, these projects use some kind of generative art tool. This is a type of digital art that uses algorithms, rules, and some kinds of randomness to create unique and original works. Instead of manually creating each individual piece, the artist can set up a group of rules and parameters in a computer program that will generate a specific number of variations. So this makes it very good at the moment of creating unique digital art that never repeats. And this ensures the uniqueness of each piece of art that you are creating. One of the benefits is the scalability, because basically with these kinds of tools you can create the collection of 10 NFTs, 10,000 NFTs, or 100 million NFTs. It all depends on the amount of possible unique traits, which is basically depending on the amount of layers you have and on how you create the rules at the moment of generating the art. The other key feature is the uniqueness. With these tools, you ensure the uniqueness of every NFT. And then you have, of course, the cost effectiveness, in terms that you don't need to create them one by one, which would take a lot of time and work. It also allows you to have some control in terms of the traits that your NFT will have. And for example, you can have multiple kinds of eyes, multiple ears, and create different traits. Then we have IPFS. IPFS stands for Interplanetary File System, and it's a peer-to-peer distributed file system that allows users to store and access files in a decentralized network. It provides a secure way that is both scalable and fault-tolerant to store and share files. This is very commonly used for NFTs because of this feature. IPFS uses a content addresses system. This means that the files are identified by their content rather by their location. So if you modify the content of your files, a different ID will be created. This ID is always linked to the content itself. When a file is added to IPFS, it's broken up into small pieces called blocks, and you get like a unique hash that represents the content. IPFS has some advantages and disadvantages. Some of the advantages are the decentralization, speed, and the scalability, because it allows you to handle a large amount of data. But it's also complex, so that's one of the disadvantages, because if you want to upload to IPFS, you will need to download and install an IPFS client. And then, once you have it installed, you can add the files into IPFS using a command line interface, which can be kind of complex, for example, for artists that want to launch their NFT projects. So complexity is one of the disadvantages, but luckily there are tools like Piñata that makes this process much easier. Another thing about IPFS is that it doesn't provide a built-in encryption tool or access tool, which might be vulnerable to attacks in terms of unauthorized access. So if someone gets to know the hash of your content, they will be able to access it, and you cannot prevent that from happening. So this is something important to consider about IPFS. And that's basically the introduction to IPFS and NFT development.